Imagine for a second, you're rolling dice, and for 12 consecutive times, numbers come up that mathematically shouldn't appear together. Coincidence? Maybe. But what if those dice were an object coming from deep space, and the numbers were scientific measurements that are making researchers' hair stand on end? That's exactly the case with 3I Atlas, an interstellar visitor that arrived in our solar system carrying more mysteries than answers. And Avi Loeb, one of Harvard's most respected and controversial astrophysicists, is saying something many people don't want to hear. Folks, there's something strange happening here, and pretending we don't see it won't make the problems go away. But hold on, let's take this slowly. Before jumping to any crazy conclusions, we need to understand what exactly is happening. Why is an object that should behave like a common comet breaking practically every rule we know? And why does the official response seem to be avoiding the most important questions? The press conference that left more questions than answers. When NASA scheduled that press conference to talk about the new 3I Atlas images, everyone expected something exciting. After all, it's not every day we get to photograph a visitor from another star system, right? But what happened was kind of frustrating. The official message was basically, "Folks, relax. It's just a slightly different comet, nothing major." But Loeb didn't buy it. He went there, analyzed the entire press conference transcript, and noticed something. The most interesting questions were kind of ignored. For example, there's an image taken by HiRISE, which is a super powerful camera orbiting Mars, that shows something really strange. 3I Atlas has a weird brightness in front of it, in the direction it's going. This is kind of bizarre, because normally, when a comet approaches the Sun, it forms a tail that points away from the Sun. It's basic physics. Sun wind pushes the comet's material away. But 3I Atlas, it has this brightness in front, like a headlight clearing the way. This doesn't make sense with what we know about comets. And when journalists asked about this at the press conference, the answer was kind of evasive. Loeb questions, if we have clear anomalies, why not talk about them openly? Science isn't about hiding what we don't understand. It's about investigating precisely these strange things. The number that made everyone stop and think. Now comes the part that really left everyone jaw-dropped. Loeb did a calculation that any physics student can verify, and the result is disturbing. Let's explain slowly. Every planet has what we call a gravitational sphere of influence. It's like the territory where that planet's gravity rules. For Jupiter, this sphere has a specific radius that varies as it moves in its orbit. In March 2026, when 3I Atlas will pass closest to Jupiter, this sphere will have exactly 53.502 million kilometers radius. Now, hold on to your chairs. Calculations show that 3I Atlas will pass at exactly 53.445 million kilometers from Jupiter. The difference? Just 57,000 kilometers. For you to have an idea, this is like hitting a coin-sized target from 100 meters away. The precision is absurd. And here comes the detail that makes everything stranger. During perihelion, the closest point to the Sun, 3I Atlas had an acceleration we can't completely explain by gravity. It was a small acceleration, but sufficient to adjust its trajectory. Coincidence? Mathematically, the chance of this happening by accident is 1 in 26,000. It's like winning the lottery, but a cosmic lottery where the prize is a millimetrically calculated approach to Jupiter. The 12 things we can't explain. Before we get to the crazier theories, let's list everything that's strange about 3I Atlas. And look, it's not a short list. 1. The impossible turn. 3. Atlas changed direction in a way that doesn't match what we expect from a natural object being pulled only by gravity. 2. The inverted tail. Instead of a tail pointing away from the Sun, it has an antitail pointing toward the Sun. It's like someone turned physics upside down. 3. Crazy density. 3. I-Atlas's nucleus is too dense to be a common comet. It's like it's made of much heavier material than ice and rock. 4. The Solar System Tour. Its trajectory passes close to Mars, Venus, and now Jupiter. What a coincidence, right? 5. Too much nickel, too little water. The chemical composition is all wrong. Too much nickel, which is rare in comets, and too little water, which should be the main component. 6. Water thirst. Speaking of water, it releases very little water vapor considering its size and proximity to the sun. 7. Strange color. It reflects light in a way we've never seen in natural objects. 8. Suspicious neighborhood. It came from the same region of space where we captured the famous "wow" signal in the 70s. 9. Sudden blue brightness. It suddenly became brighter with a bluish color that doesn't make sense. 10. Impossible jets. The material jets it emits are too intense for the nucleus size. 11. Ghost acceleration. It's accelerating without losing visible mass, which breaks basic physics laws. 12. Stable beacon. The jets maintain the same direction for enormous distances, without oscillating with the object's rotation. What if it's not natural? Here's where things get really interesting and controversial. Loeb raises a possibility that many scientists prefer not to discuss publicly. What if 3I Atlas isn't a natural object? I'm not talking about green aliens with big eyes. I'm talking about technology. A probe, perhaps. A device created by a civilization that has existed for millions of years and has technology we can barely imagine. Think about it. If you wanted to send a probe to study a distant star system, how would you do it? You'd probably program it to make trajectory adjustments, use planetary gravity to save fuel, and maybe even deposit smaller equipment in strategic orbits. 3. I-Atlas's behavior is consistent with this. The jets could be thrusters. The brightness in front could be a protection system against micrometeoroids, like a particle shield that clears the path. And that precise approach to Jupiter, perfect for depositing something in the gas giant's orbit, something small that would stay there studying the planet for decades or centuries. But what about the skeptics? Of course, not everyone buys this theory. Many scientists argue that the universe is strange enough to produce bizarre natural objects. After all, we discover crazy things all the time. Black holes, neutron stars, planets made of diamond. And they're right to be cautious. Extraordinary science requires extraordinary evidence. But here's the problem. To have evidence, we need to look for it. And if we keep assuming everything is natural, we'll never find evidence of technology, even if it's right in front of us. What we should be doing. Loeb's frustration is legitimate. We're not investigating 3I Atlas as we should. We have fragmented data collected by different instruments, at different times, without a coordinated strategy. We'd need continuous observations, detailed spectroscopy, thermal analysis, multiband monitoring. It's like trying to assemble a puzzle with half the pieces missing. And there's more. If there really is a possibility that 3I Atlas deposited something on Jupiter, we should be prepared to detect new objects in the planet's orbit, objects we didn't send there. What this changes for us. If 3I Atlas is really a natural object with bizarre properties, that's already incredible enough. It means the universe still has a lot to teach us about how matter behaves under extreme conditions. But if it's technological, well, then everything changes. It means we're not alone, and that there's intelligence out there capable of interstellar engineering. Not necessarily contemporary intelligence. It could be a probe sent millions of years ago by a civilization that doesn't even exist anymore. Einstein once said we should look both ways before crossing the street. In science, this means considering all possibilities, even those that make us uncomfortable. 3. I-Atlas forces us to make a choice. We can accept the simplest explanation and move on, or we can seriously investigate these anomalies and see where they lead us. Regardless of the answer, one thing is certain. 3I Atlas's story is far from over. And each new observation, each new piece of data, brings us closer to the truth, whatever it may be. So keep your eyes on the sky, your mind open, and let's see where this journey takes us. Because if there's one thing science has taught us, it's that reality is always stranger and more incredible than we can imagine.